Session, and we will be having our chemistry class today. For revision, you already have done this chapter, and we are going to revise this chapter once again for better understanding. This is the first slide, and this is the chapter's name, which is exactly the picture is exactly as it is given in your book. I have taken the screenshot of this from the book only. Let's recapitulate shortly, in short, about matter. Matter can be solid, liquid, and gas. Matter is that occupies space and have some mass. And you have studied already in standard 6. So matter can be divided into two parts, that is pure substances and mixture. Now what is pure substance? Pure substance, when a substance is made up of same kind of particle, then it is pure substance. Only one kind of particle or one kind of atom. If we say particle, it can be atom or molecule. So pure substance can be either of atoms or molecules. For example, elements are made up of same kind of elements, same kind of atoms. Just for example, if I take gold, even the tiniest, the last part you can divide will remain gold only. So element has unique type of atom, a particular type of atom. If I talk of iron, if I talk of copper, all these have same kind of atoms. If I'm talking about copper wire has all atoms. Copper has all the atoms of copper only. Whereas if we talk of compound is made up of molecules. We will get to know more about in the next slides. Whereas mixture, matter can be mixture, just like you eat the mixture that is there in the market. A mixture, what is there? In mixture there are different kinds of pulses and rices are mixed to have it. So here in chemistry, when we talk of mixture, it is the combination of two or more substances that have not combined chemically. It means you can separate it physically. So matter mixture can be homogeneous and heterogeneous, that you already know. Homogeneous, that looks whose consistency is same throughout the mixture, whereas heterogeneous is have a different concentration in the mixture. Let's move to the next slide. Dear students, it is important to understand the pure substance that is divided into elements and compounds. Now see here, elements can be atoms or molecules, but here in molecules, see, we have taken the example of oxygen. We haven't, molecules can be water molecules, that is H2O, but it cannot be element. You understand this? Atom, that is here we have taken the example of neon, and here it is the example of oxygen. These are the same kind of the atom, same kind of particles. Elements, pure substance, elements, same kinds of atoms or molecules. Molecules means this, if it is oxygen, it is O2. It is not like that NaCl or H2O or H2SO4. It's not like molecules. Those are also molecules, but here we are talking about same kind of particles. Okay, now come to here, this is compound, this is also pure compound, pure substance, and it is just like I give the example of H2. When the molecules, when the atoms are chemically combined to form a different compound whose characteristics are entirely different from the combining elements, combining atoms. And ions, we will get to know more about it in the next class. So this is one example of atom versus molecule. Atom, that is helium atom, and here it is hydrogen molecule. This is H2. It is helium atom, one atom, and here it is molecule. When we are talking about H2 or O2, then it is molecule, whereas when we talk about H2O, it is compound. Now, please understand this, particles can be atom, molecules, or ions. Atoms are single neutral particles. Now, what do you understand by neutral? Neutrals means which doesn't have any charge. It remains, it is neutral. Uh, it doesn't have positive or negative charges. Similarly, molecules too are neutral particles made of two or more atoms bonded together. An ion is a positively or negatively charged particle that you have studied in forming formulas like sodium Na plus, like this ammonium NH4. Okay. Now, what are elements? An element is a pure substance that cannot be broken down into other substance. Means when if I take the example of iron, it cannot be broken down into other substance. It means the iron will remain irons to its smallest part, smallest. Even if we break it into whatever we may try, we cannot find out any other substance, other element from iron or any element. Okay, so each element can be identified its specific physical and chemical characteristic. Now, what do you understand by specific physical and chemical properties? If I say gold, gold has physical property of that it looks, it is yellow, it has luster, it shines, it is malleable, it is very costly. And chemical properties, it has very high boiling point or melting point. It doesn't combine easily, whereas when we talk about sodium, it has white color, it is soft, it burns in air. There are different things that you will get to know more about in next classes, senior class. Let's have a clear understanding about elements that you have just known, that just come to know. And you already know maybe that elements is a pure substance that cannot be broken down into any other substance. If I take gold, it cannot be broken down into other substance. Just like if we take water, H2O, it can be broken down into hydrogen and oxygen. But if we take gold or iron or copper or carbon or oxygen, it cannot be broken down into some other element. Okay, so each element can be identified by its specific physical and chemical properties. Now, what do you understand by physical and chemical properties? Suppose I take gold. Gold has a physical property that it is its color is yellow, it is shiny, uh, mm, it is very costly, it is not easily available, and it is very malleable, means you can make a thin sheet out of gold. So it is a very ductile, means you can make a thread, like even you can make the thread of a gold. Okay, so it is its physical character. What about the chemical properties? Chemical properties means how it reacts to, how it behaves to the other elements. So if we talk about gold, gold is not a very active element in a periodic that reactivity series. You will get to know more about in the next class about reactivity series, that it doesn't react with the other elements very easily. So each element is represented by one or two letter symbol. We will get to know more about the symbol. So carbon is indicated by C, oxygen O, hydrogen H, aluminum Al, and elements are made up of particles called atoms. Fine. So elements have different properties because their atoms are different. Let's move to the next slide. And what is the difference between elements and compound? Compound, now see here, you must have seen the what did you say, the periodic table. In periodic table, there are about 118 elements. 118 elements are there, and only elements are there. You cannot find compound. You cannot find a compound in periodic table. Have you seen H2O in the periodic table? No, because only elements has been given its place in the periodic table. So element consists of only one kind of atoms, whereas compound always have more than one kind of atoms, like H2O, like NaCl, like H2SO4, sulfuric acid. These are compounds which have more than one kind of atoms. Elements we cannot divide into, just we have read in the previous slide that elements cannot be divided into two or more simpler substance by physical, because there is no other substance in it. It is pure substance. Compound too is pure, but when it can be separated from its separated, divided into its elemental form, like H2SO4, like it can be separated H2, hydrogen, sulfur and oxygen. Okay, and elements are only 118 that is there in the periodic table, whereas compound can be, there is unlimited number of compounds which can be chemically formed by chemical reactions. This is the activity. On the basis of that you have studied that pure substance and mixture. You can well understand this. This is air is a mixture, iron is a pure substance, water is a compound, that is pure substance. Of course, water is pure substance. If there is no other mixture in it, soil is a mixture, lemonade is a mixture, gold is element, whereas oxygen too is. What is it? Jaldi batao. This is oxygen again. It is pure substance. Let's move to the. Okay, you have come to know about matter, that is solid, liquid and gas. You have come to know about atoms and about molecules, that atom combines to form molecule. You have come to know about element and compound. All these are pure substances. You already know about mixture, and air is a mixture, and there are so many mixture that you see in your daily life. Okay, so let's move to the next part, that is chemical symbols. So why exactly is chemical symbol is required in chemistry? So chemical symbols is essentially the name of the element, a unique name to each element. Now tell me, there are about more than 100 elements in the periodic table, and there are only 26 letters, 26 English alphabet. So how 26 alphabet can be given to elements, all the elements? So scientists used symbols, different symbols for representing each element, but it was very confusing and it was very difficult to remember. Thereafter they devised an idea to give the name to the elements with the first letter of its name. Like oxygen, it is already there. Oxygen is represented by let me see, oxygen is represented by O, hydrogen is represented by H. Whereas if I say copper, it is Cu. Okay, first let me tell you, there are four ways of has four there are four ways to give to assign the name symbols to each element. First way is given first alphabet, second first two letters of the word, that is first two letter, that is aluminum or neon or manganese, first two letter. Okay, third is any prominent letter, like chlorine. Chlorine, the spelling of chlorine is CHLORIN, chlorine. Okay, but We do not write CH, we write Cl, right? We write Cl. Zinc, zinc, the spelling of zinc it is ZINC. But what the symbols, what it has been given, the symbol of zinc is Zn. So this is the third way. First letter plus the next letter of that word. And fourth is it is derived from Latin or German and other language, like uh, iron. Iron. This is Fe, ferrum. It is taken from Latin word. Ag, Argentinum. That is taken from again Latin. This is silver. And Na, again from Latin. That is natrium. Potassium. K. Now see here. K. Potassium. Carium. So these are the different symbols that is given to the different elements in the periodic table. Let's move to the next slide. Let's see what's there. And this is exactly you have seen many a times in your book. The chemical symbols like hydrogen is given by H, magnesium, Mg, aluminium. So see the different types of different symbols given to different elements in the table. See here again the name. You just you do not have to worry that you cannot remember these words, these symbols. It's very, once you start practicing the chemical formulas and writing equation, you will learn it by heart. It is not very difficult. Now, what is chemical formula? Now, this is where we need the chemical symbols. Chemical formula of a substance is based on the composition of that substance. It indicates the type and number of atoms of each kind present in that substance. Suppose I take one example of HNO3. Can you tell me what is its name? This is nitric acid. In this nitric acid, one atom of hydrogen is used, one atom of nitrogen, and three atom of oxygen. And how many atoms are there? There are all five atoms. So this is chemical formula. Now tell me how it is formed. How you would know that it will be nitric acid will be written like this only? For this, you will have to learn cations and anions that is given in your book. That is given in your book. Cations, that is positively charged particles, positively charged ions, and positive ions are, I'm not able to write it here properly, but try to understand. And anions are negatively charged. Okay, one example of you can see the book, that is Na plus. This is cation. And if we'll talk about anion, simple example is one chlorine. You will get to know how this positively charged anion or cation or negatively charged or anions are formed. In it is all about atomic configuration. Okay, atomic configuration we will study. So this is what Venn diagram, that molecules can be elements, can be compounds, can be elements. If I say molecules can be elements, then I say oxygen, then I say nitrogen, N2, I say chlorine. These are elements. And when I talk about molecules, it is H2O. Okay? Means elements can be elements elements can be molecules, and elements can be atom. Like atom, for example, Au, gold, atoms of carbon, atoms of sodium, right? And compound can be molecules. This is H2O. This is also compound. So I think that it is pretty clear. One more, let's see the example: copper atom. Where is NaCl, NaCl molecule as well as compound. Let's move. And this is the simple, I have, this is, brain map of the whole chapter that you have learned in standard 6 chemical. This is matter, and you have seen that can be classified into different, that there may be chemical change, physical change, and we are studying about this in stand 7. We are studying about this, and you remember you have studied this in standard 6 in separation of substance and all. I'm sure you remember this. And this is again the summary. If you will go through it, if you will remember this, there won't be any confusion in this chapter. This is all about mixture and pure substance. What is the difference between mixture and pure substances? Mixture and pure homogeneous. This is about mixture, and mixture versus pure substances. Here, leave it. Yeah, this is not okay. You can skip this, but this is the way of learning. This is brain mapping, and this is the easy way of learning the whole chapter. Okay, some mixture versus substances. You can see this. I have just made this slide for better understanding. Once you have this in your mind, you need not remember so much of the text. So don't you worry, because you may be finding that there are so much text, but it is not like this. It's simple that whatever you have learned, it is in summary. Mixture versus pure substance. A single element is an example of pure substance because it cannot be broken down into the simpler substance that you have already studied in previous slides. Okay, so in next class we will continue to continue with how to form formulas. Okay, till then wait for the next class, and we will be learning, we will be revising in fact how to form formulas. Okay, thank you. Bye bye. Bye bye.